let's try to understand why the root of a quadratic equation is termed as equal roots, distinct roots, or real roots, and complex or imaginary roots. Let's begin with distinct roots. We say roots are real and distinct when after solving a quadratic equation, you end up getting two different roots. Let's say two different answers. For instance, in x squared minus 5x plus 6, if we are to factorize this completely, we'll end up getting x to be 2 or 3. You realize that 2 is different from 3. That is when we say the root is a distinct or real root. Now, another way to find or to indicate this is by using the discriminant. And we said that for us to find a distinct root, the discriminant b squared minus 4ac should be greater than 0. In this case, let's compare the equation given with a general quadratic equation. Now, the general quadratic equation is ax squared plus bx plus c. Now, in this case, our a is 1, b is minus 5, and then c is 6. So let's put these values in the discriminant. Now, b is minus 5, so minus 5 squared, b squared minus, so 4 times a is 1, times c. This tells us that b squared minus 4ac. Now the value is 1. Is 1 greater or equal or less than 0? You realize that 1 is greater than 0. So this discriminant is greater than 0. We said that when b squared minus 4ac is greater than 0, it is termed as a real or distinct root. So to save us the stress of going over to solve it either by factorizing or by using completing of squares, you just use the discriminant and then you're good to go. Complex or imaginary roots, let's take this as an example. Let's use the general quadratic formula to solve this to find out what the outcome will be. What roots are we going to get? So we've stated root. You realize that these are complex answers, and because with a negative, should we continue, we are going to get an error. So that is why it is imaginary root or complex root. Complex or imaginary root, we said that b squared minus 4ac should be less than 0. So in this case, our a is 4, b is 2, 3, and then c is 3. So let's go and put that in. So 4 minus we said that b squared minus 4ac when it's less than 0. After solving this, we realized that we had minus 44, and that is less than 0. So that we say an equation has equal or coincident roots when after solving the quadratic equation, you end up getting the same roots. So the same value for x. If we are to solve this, so you end up getting the same values for x. This is when the roots are termed as an equal root or coincident roots. For us to use the discriminant to indicate whether the root of an equation is equal root. Now, it is said that the discriminant b squared minus 4ac should be equal to 0. The value for a in this equation is 1, b is minus 8, and then c is 16. But we said that if the discriminant is equal to 0, then it is termed as an equal or coincident root.
It's question time!
Now from the question given, we're given two clues. We're given the equation, and then they said that the equation has equal roots. So in this case, the equation has equal roots, but we know that for an equation to get an equal root, then its discriminant should be equal to 0. So if that is the case, then let's find the discriminant out of this equation, then equate it to 0. Now by comparing it with ax squared plus bx plus c, now our a, the value for a is now k, the value for b is 12, and then the value for c is 9. And we know that our discriminant should be equal to 0. So k is now 4. Question 2. It was also stated that this equation has equal roots. So that means the discriminant of this equation should be equal to 0. Now for us to get a discriminant, let's compare this with the general quadratic equation. So by comparing, a is equal to, this is the x squared term. What is in front of the x squared term is 1. So a is 1. B is equal to, now this is the x term, and this is the x term. The entire thing here is b, which is p minus 2. And c is the constant term. So the entire thing here is the constant term, p plus 1. Now we know that for root of equation to be equal, then the discriminant b squared minus 4ac should be equal to 0. Now we have our b to be p minus 2, so p minus 2 and the squared, so squared minus 4 times a is 1, times c is p plus 1, and we are saying equal, so it should be equal to 0. This is the discriminant. The discriminant should be equal to 0. Now we can simplify this further. So this is the same as p squared minus 4p plus 4. And this is the trick. You just square the first one, then you multiply this by what is inside the bracket. So 2 times p is 2p times another 2, which is 4p, so minus 4p. Then you squared this last one, which is minus 2 squared is positive 4. So that is how I had that one. And let's expand this one. 4 times 1 is 4. So 4 times p. Now let's do it this way for you not to get lost. Now we have p squared minus 4p plus 4 minus 4p minus 4 is equal to 0. We expand the bracket here. So now we can group like terms. So we have p squared minus 4p, which is minus 8p plus 4 minus 4, so that will be 0. Then we can factor p out. So p minus 8 is equal to 0. Now let's equate this to 0. P is equal to 0, or p minus 8 is equal to 0 for us to get p to be 8. So the values for p are 0 and then 8. And 3, we want to find the value of a for which this equation have equal roots. Now first of all, for us to get an equal root, then the discriminant of this equation should be equal to 0. Let's bring this one here in order for to compare with the general quadratic equation. So we can rewrite this as b. Now b is the x term. So what is in front of the b? The coefficient of b is the entire thing, 3a plus 1. C. Now c is the constant term, and everything here is the constant term. So e squared minus 1 minus 5a. From here, we'll have to solve this either by using completing of squares factorization or the general quadratic formula. Well, let's use the general quadratic formula. But a is 5, b is 26, and then c is 5. So we end up getting this x to be minus 1 on 5 or x to be minus 5. So that is a value for a. Let me make it a. So a to be minus 1 on 5 or a to be minus 5.